In this segment, we will define the intersection and union of sets. And I have a rather formal definition for you and then an example. An intersection has us examine any sets. We'll look at two sets, A and B, and the intersection is symbolized with this sort of upside-down horseshoe figure. And we write A intersect B, and it's given by the set of all x such that x is an element of A and x is an element of B. What does that mean? It means we've got this group of objects or things, and we're going to call each item in that group x. If x happens to live in set A and set B, both at the same time, then it's part of the intersection. And we can draw a picture of what this looks like. If we have some set A, and it's got a number of elements in it, and some other set B, the place where those sets overlap is the intersection of those sets. We can do something similar for the union. With a union, symbolized with a U, or a symbol that looks a lot like a U, we have any two sets, we'll call them A and B again, and they have a bunch of things in them, we'll call those x. Well, if x is an element either of A or of B, then we're going to include it in the union. So with the union, we take everything. We can draw a picture again. Here's our set A. Here's our set B. They may overlap, but whether they overlap or not, we take everything that is in both of those sets. Let's look at an example. Consider a set A, and it's going to have a few even numbers in it, 2, 4, 6, and 8, and a set B that has some prime numbers in it, 2, 3, 5, and 7. If we look at the union of A and B, we take everything, 2, 3, 4, 5, 6, 7, and 8. If we look at the intersection, we must find those numbers that are in both sets at the same time, and the only number we have that does that is the number 2. It lives in both A and B at the same time, and so the intersection is a set with exactly one element, the number 2. That's the end of this example.